Hi, welcome to the video tutorial for a lesson called Who Dunnit. It's not in the original Thinking Maths materials. It's originally designed for Year 6, but I think it's got a lot of potential. And there's a couple of the activities from the Year 6 materials that I think bridge very well into some of the things that people have got to do at Key Stage 3 and Key Stage 4. So this lesson is called Who Dunnit. And what I like about a lot, so there's a mixture of ratio, data handling, what are we going to do with the data? What are we going to do with the data? You decide what you want to do with the data. It's that kind of lesson. It's lovely to put the onus on the pupils to make decisions, because often we don't allow them to do that and discuss it. And I think it's important that this is a strand of maths that we really want them to become accomplished with, because we're all used to Key Stage 4 classes sitting there, not having a clue, just sitting there, useless. And it isn't an understatement. It's not understating the problem that some children just sit there and have not got a clue. We've all heard reports from children going on work experience where they just sit there and they have no initiative, they have no sense of, I'll try this. So that's what this lesson's about. You're putting them in a situation where they've got to make sense of the data. The scenario is there's been a break-in, real or imagined, but there's some evidence left in the classroom. A hat and a glove, and we've seen two people running away. One's quite large, one's small in height terms, and the question is how can we find out if there's a link between how big the person is and the objects that they wear? So again, you're setting up a hypothesis that there's a link between how tall you are and the clothing that you wear. I've picked these deliberately, and I'll explain why at the end of the at the end of the lesson. So you give the pupils a chance to talk about what the police might do, might there be links, and just let them share their idea. They talk about taking DNA and all the stuff they've seen on CSI. But you come back to the question, is there a link between the size of the hat and glove and the size of the wearer? So, what you do is you measure the circumference of the hat, and the circumference of the hat is about 50. You measure the length of the glove from the wrist to the tip of the finger, and the glove is about 20. So you say, okay, is there a link between those and how big the person is that wear them? What other measurement do we need? Oh, we need to measure our height. How much direction you give them is up to you, but the idea is that we now need to measure the height. So, okay. Off you go. They measure for themselves 3 measurements. The circumference of their head, their hand, and their height. So you would end up with, say, for each child, you would have your height is 157. Your hand is 15. And your head is 51. So the first, on the PowerPoint I use, I just say, what are we going to do with the data? You've got 3 numbers, what are you going to do to look for links? And often at this point, children will just send them at them, take away them. Is that going to help us find links between how big you are and these things? Because ultimately you want them to do the division. How many times does your hand go into your height? How many times does your head go into your height? Or how many times are we bigger than our hand? How many times are we bigger than our head? But you don't tell them that. You've got to let them think, how can we explore this link? So, after a bit of discussion, they might realise that, okay, we're going to do 2 sums here. We're going to do your height divided by your head and get a head number. And we're going to do your height divided by your hand and get a hand number. And you give them the calculators and you ask them to do that. And what you get them to do is you get them to come and write those values on the board. So let's have head numbers over here and hand numbers over here. So remember, it was height. Some of them can't even do this. They'll do it the wrong way around. And that's good practice. You don't tell them they're wrong, they just realise it. And then you've got your height divided by your hand. And I think it's lovely to give children the opportunity to make sense of data, to look for patterns, to try and see things in the data. Often we give them too many answers, or everything is formulaic. Here, the numbers are messy, and they've got to make sense of them. And I think there's an interesting overlap between maths and science, where you've got real numbers, and the patterns aren't tidy. And they've got to do things with the numbers to make sense of them. That was my experience of, it wasn't until I did A-level maths, I did my degree, where I had to start doing things like that with numbers. And I wish I'd practiced much earlier. So what starts to happen is, they start to write all these numbers on the board, and the more you get, the better. So you end up with something like 3.21478, 2.936148, 3.57612, 2.87641, a whole range of numbers on here. Some of them will get them swapped round, and I quickly realise that. For the hand number, you end up with things like 7.94321, 8.643632216, 9.2476332, 8.9363636. So you end up with a load of numbers on the board that the children find fascinating, because normally they're used to numbers that are rounded. Here, they just write the whole number out. And you say, okay, what are we going to do with the data? What do you think we should do to make sense of it? And what's interesting is, children often don't understand numbers as meaning anything. They just see it as a number. This number tells us something about our body, but they don't actually understand that. They've not been made to think about it. So you end up in a situation where the children often will sit and not say anything. And someone might say, well, actually, I think this number here, this number's about 3. Some of them will decide to round it. Some of them won't know anything. Some of them will say, oh, there's an 8 there and an 8 there. They look for individual digits. They won't see the sense of what the number means. Some of them will say, oh, there's 2 on there, there's 2 on there. Another one will say, well, that's about 8 or 9. Because what's interesting in this lesson is there is an inbuilt challenge in the fact that we're picking a range of data and coming up with a middle value. And is that helpful in coming up with a conclusion? It might be, it might not be. So there's avenues for people to share their thoughts about what's going on with the numbers. But after a while, they will realise that this number's about 3, this number's about 8 or 9. You say, well, okay, what does that mean? What does that actually mean? And that can take them a while to realise that that means we're 3 times bigger than our head, we're 8 or 9 times bigger than our hand. That, for many of them, and it's the same in the next ratio lesson we're going to look at, is a revelation that, hang on, you're bigger than me, but our numbers are still 8. They've not thought about ratios in terms of proportion. And it's really important to let them process that and reflect upon that and think about that and realise that, well, hang on, you're the same as me, but you're bigger than me. And to realise what's going on here. But the clincher is that we're 3 times bigger than our head, we're 8 or 9 times bigger than our hand. And obviously you can go back to the hat and glove at this point, where the hat was 50 centimetres, the glove was 20, and the question was, do they come from the same person? Well, this person is about 150 centimetres tall, this person is about 180 centimetres tall. Oh, it's not from the same person, sir. That's my glove, that's my wife's hat, she's under 5 foot. So they can't be from the same person. So that is a very rich lesson that will take a full hour or possibly longer. It's a very, very active lesson. It's a bit like the desk lesson, where they're measuring and they're using measurements, and it addresses lots of misconceptions, and it's a very rich problem-solving activity, which for me is just, what are we going to do with the data?